Hello and welcome to this presentation for Theme 3 of A-Level Business, and this one is on 3.3.1 Quantitative Sales Forecasting. So what do you need to be able to do? Well, you need to be able to calculate the 3-point or 3-period moving average. You need to be able to extrapolate using a line of best fit to generate sales forecasts, and you need to be able to calculate the average variation and use this to adjust your sales forecast. So you learned about sales forecasting last year a little bit, but just to recap, sales forecasting is a method of predicting future sales, and we do that using statistical methods. But why would a firm want to actually produce sales forecasts? Why would they want to predict the level of sales going forward into the future? Well, from a financial point of view, sales forecasting can be very helpful. For instance, when producing cash flow forecasts, and you know all the reasons why those are useful. From an operational point of view, sales forecasting can help in all sorts of ways, such as planning orders, organising the production process, and working out the required stock levels in the future. From a people point of view, a good idea of future sales can really help with human resources planning. For instance, making sure that the right people are recruited or trained, or perhaps even made redundant if sales are forecast to fall. The data can also be very useful for setting sales targets for managers, and that can be useful for motivational reasons and also to give the business something to measure its performance against. And lastly, from a marketing point of view, sales forecasts can be very helpful, for instance, when planning promotional campaigns. If sales forecasts suggest a potential dip in sales, perhaps due to a change in the external environment, like an interest rate rise, the marketing function could devise an appropriate campaign to try to offset the effects of this, say, potential rate rise. So within all the different departments in a business, sales forecasting is very helpful in helping them to get organised and plan for the future. But how do we do it? Well, the statistical technique that we are going to use to generate a sales forecast is called time series analysis. And this is a method that uses past sales figures to predict future sales. And you'll need that definition, so please make sure you've got it down. It's a very straightforward technique, and once you've done it a few times, you'll see that that's true. So what do you need to do? The first step is to collate or collect the raw sales data and record it in time order, like in this table here, where you've got the year on the left and you've got the sales, in this case in pounds million, on the right. The idea behind time series analysis is to identify trends in sales in the past by looking at raw sales data. The difficulty is that sometimes sales data can be a little volatile, making it harder to identify an overall trend. For instance, here, looking at this table, can you see the trend? It's actually quite hard to identify it looking at that. It looks a little bit kind of up and down. So to help us see the overall trend in data more easily, what we do is we smooth out the raw sales data by doing something called calculating moving averages. And this is very straightforward, and I'll show you how to do that on the next slide. So how do we calculate a moving average? Well, we're going to start by doing the easy one. We're going to start by calculating a 3-point or a 3-period moving average. So we've got our data there that we had on the previous slide, and what we're going to do is we're just going to work down the data and gradually calculate the average of sales over 3 time periods. So first step that you need to do is work out the first moving average. So you take the first 3 periods of data, so our first 3 periods are here, 2003, 2004, 2005. We add up sales over that period. So 67 plus 70 plus 64 give us our total, and then divide our total by 3. And that gives us our average level of sales over those 3 years as being 67. And here it is, written down here in our table, 67. And then we simply repeat that for the next set of sales figures. So we move on. This time we leave out 2003 and we move forward. And we take the sales data from 2004, 2005, and 2006. So there's our data that we need there. 70, add 64, add 61, add them all together and divide by 3 gives us our average sales for that period, or our 3-point moving average of 65. And we write it here. And then you simply continue. It's important to remember to write the moving average at the center of the 3 years. So that's why I've included this here so I can show you. 67 is the 3-point moving average for those 3 periods, 2003, 4 and 5. So we write it right there in the middle. So what I'd like you to do now is actually pause the video and move on and have a go at calculating the next 2 3-point moving averages yourself. Okay, can you do that now, please? So how did you get on? Hopefully you managed to get these correct and you've worked out these 2 figures to be 61.33 and 62. Okay, so let's move on now. Once you've actually calculated all of the 3-point moving averages, the next step is to plot them on a graph and draw a line of best fit to illustrate the trend level of sales. So let's take a look at this now. So on this chart, you can see that I've got the years down here along the x-axis, and you'll see that I've got sales in pounds million up here on the y-axis. And this blue line here shows the actual value of sales in pounds million, and you can see that's very volatile. And then this red line here shows you the 3-point moving average that we calculated on the previous slide. And you can see that that's smoothed out these big fluctuations that we can see in the actual data. And that hopefully should make it easier for us to see the overall trend. So once you've done that, once you've plotted the 3-point moving average, you can use that to draw a line of best fit and see the trend. So here you can see on this slide that we've got the line of best fit, which we've just sketched through the 3-point moving average line. So very easy to do, just a kind of estimate of where the line of best fit would go that you would have done at school in maths. So we're up to step 3 now. You've looked at the raw sales data in time order. You've smoothed out any variations by calculating the 3-point moving average. You've drawn a line of best fit through the data to illustrate the trend. The next step is actually to extrapolate the trend. This means we extend the line of best fit forward into the future to get our sales forecast. So on this chart, you can see that the line of best fit here has been extrapolated forward to enable us to make a forecast. So using our extrapolated line of best fit, we can see that in 2017 here, sales are forecast, read up to our line of best fit, sales are forecast to be approximately £71 million. So that's how we use our line of best fit extrapolated into the future to forecast sales. So you thought we were finished, right? Well, not quite right. There's one more step that we need to do before we finish. We need to adjust for variation. Step 5, we need to adjust for variation. And this is also very straightforward. The trouble is, when you're reading from a line of best fit, it might not be very accurate, as it doesn't consider the fluctuations in the data because these have been smoothed out. So to make a more accurate prediction, we can calculate the average variation and include this in the forecast. And this is calculated using the formula variation equals actual data minus trend data. So make sure you write that down now, please. So how do we actually adjust for variation? Well, this is very straightforward, as I say. First thing you need to do is calculate the variation for each year using the formula that you just wrote down, which is variation equals actual data minus trend data. For instance, for 2004 here, actual data was 70. Our trend data, or our 3-point moving average data, was 67 million. So our variation was 3. In this case, it was £3 million. So we do that for every row here. So for 2005, actual data was 64 million, 3-point moving average was 65, so our variation is -1. And we just keep working down every year and work out the variation for every year that we're considering. Once we've done that, we calculate the sum of these variations. So very simply, we add up all of the variations that we've got here in the list and get the total. And in this case, the sum of the variations is 6.67. Okay, so that's step 2. Let's take a look at step 3. Step 3 is calculate the average variation by dividing the sum of the variations, which we've worked out here to be 6.67, by the number of variations that we are considering. In this case, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we take the total, 6.67, and we divide that by how many we've got, which is 11, which gives us an average variation of 0.61. So that's step 3. Now, what we need to do with that is we need to take our average variation, we need to use that and add it to any reading that we take from our line of best fit, and this will improve the accuracy of our forecast. So just looking at our example that we've been considering, so we calculated that our average variation for this data was 0.61 million. So what we need to do is add this to our reading from our line of best fit. So our line of best fit forecast that sales in 2017 would be 71 million. So if we need to adjust that for variations, what we do is we forecast that sales will be 71, which we read off from the line of best fit, plus our average variation of 0.61 gives us a forecast of 71.61 million. So that is what you do to adjust your forecast for variations. So what you needed to be able to do following this presentation was to use time series analysis to calculate 3-point moving averages, to extrapolate using a line of best fit to generate a sales forecast, and then to calculate the average variation and use this to adjust sales forecasts. So hopefully you're able to do that now, and we'll do lots of practice in class to make sure that you're really confident with it. Thank you very much for listening.